This lesson is the first derivative test. This is section 2 of Unit 4. Let's start by looking at sketching of curves or functions. So let's say we had a function, f of x is equal to x cubed minus 3x squared plus 2, and let's say we wanted to sketch the curve of that function. So let's start by looking for the critical points. So we're going to find those critical points by taking the first derivative of this function. So if we look at this function up here, all right, and we take the first derivative, let's look at the first term, x cubed, that simply becomes 3x squared. Then we got minus 3 halves x squared. So it's going to be the exponent minus 2 times 3 halves times x to the 1 less. Derivative of 2 is 0. That comes out to be 3x squared minus 3x. All right? Now, to find the critical points, we're going to set that equal to 0. So first thing I'm going to do is simplify this by taking and factoring out the 3x. So that gives me 3x times x minus 1 is equal to 0. Well, 3x could be equal to 0, in which case we'd have x equal to 0. Or x minus 1 could equal 0, in which case we have x is equal to plus 1. So our critical points in this case are going to be 0 and 1. So let's create a table here, okay? And we've got intervals, okay? Test values, derivative, and conclusion. Now here are our critical points, 0 and 1. And the intervals are going to be from minus infinity to 0 is going to be right here. 0 to 1 is going to be right here. And 1 to positive infinity is going to be right here. So let's continue and fill in the rest of this table. So I want to look for test values. So for a test value less than 0, I'm going to pick minus 1. For a test value between 0 and 1, I'm going to pick 1/2. And for a test value greater than 1, I'm going to pick 2. So now if I take these test values and plug it into the derivative equation, which is over here, we'll see that at x equals minus 1, the derivative is positive, okay? All we're concerned with is whether it's positive or negative. We don't really care what the actual value is, just is it positive or negative. If I plug in x equals 1/2 into the derivative, I get something that's negative. And lastly, if I plug in x equals 2 into the derivative function, I get something that's positive. Well, look at what's happening here on both sides of the critical points. So initially, we are positive to the left of 0. Then we're negative between 0 and 1. And then we're positive again to the right of 1. So we can see that we're in this first region, we're increasing. The second region, we're decreasing. And the third region, we're increasing. So if I were to roughly sketch this out, I would see something like this. That it would be going up here, then down here, and then back up like that. So I'd have a max at 0, relative max at 0, and a relative min at 1, okay? So that would be the rough sketch of what the graph would look like. So now, let's use the first derivative test to find the extrema of this particular function. So the first thing, obviously, that we're going to do is take the first derivative of the function. And if we take the first derivative of the function, we have the exponent, okay, here, 2/3. Then we take this sum here, keep it the same. The exponent minus 1, that becomes minus 1/3. And then the derivative of what's inside the parentheses becomes 2x. And if I were to simplify that, I come out with 4x, over 3 times the cube root of x squared minus 4. So that's the first derivative. That's the first step we're going to take. So next, we want to find the critical points. So when we've got a rational function like this, the critical points are going to occur when the numerator equals 0 and where the denominator equals 0. So we simply set the numerator equal to 0. That's pretty straightforward. 4x equals 0, or x is equal to 0. Then we take the denominator, and where is that going to be equal to 0? That's simply going to be equal to 0 when x squared minus 4 is equal to 0, or x is going to equal plus or minus 2. So these are the critical points. So now, rather than use a table, let's look at this somewhat graphically. Let's assume we got like a number line. Here are our critical points. We've got minus 2, 0, and plus 2. So what we're concerned with are these regions to the left of minus 2, between minus 2 and 0, between 0 and plus 2, and to the right of plus 2. So if we pick some test values to the left of minus 2, we can come up with, for example, minus 3. And again, all we're concerned about is whether the derivative is positive or negative. And we see that to the left of minus 3, it's negative. At minus 1, which is between 0 and 1, it's positive. Between 0 and 2, so if I take the derivative, the value of the derivative at plus 1, it's negative again. And then at plus 3, which is to the right of 2, it's positive. So remember what we had here. We had negative, positive, negative, positive. So from this, I can tell that there's a relative minimum at x equals minus 2, because the derivative changes from negative to positive. So that tells me that's a relative minimum here. Next, between minus 2 and, at 0. Between minus 2 and 0, it's positive. From 0 to positive 2, it's negative. So this tells me that there's a relative maximum at x equals 0 because the derivative changes from positive to negative. So lastly, we know that at x equals plus 2, since the derivative is negative here and positive here, that there's going to be a relative minimum at x equals plus 2 because the derivative changes from negative to positive. So here is a quick way of seeing how we can use the first derivative test to find various extrema, or basically relative maximums and relative minimums for a particular function.